Now see the part number 5. Part 5, coordination compound. Coordination compound. See the question number 13. A magnetic moment of, so mu value is given 1.73 for magneton, will be the shown one of the following. It is asked in Neet 2013. Right. So Bohr magneton value you have to given, that is 1.732. So you can find the number of unpaired electrons. So formula is mu equal to under root of n into n plus 1. Right. So it is 1.73 the whole square, right? I am squaring both sides. So it will be a square equal to n square into n, right? So after solving this, you will get n equal to 1, means unpaired electron is 1. Unpaired electron is 1, right? So the complex having one unpaired electron exhibits magnetic moment, right? So here, look at the option number CuNH3 4 raised to 2 plus, right? So this is your copper, right? So atomic number will be, so it is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, right? Zinc comes at 30, so it will be 29. So its electronic configuration will be argon 4s2 3d9, right? But after losing 2 electrons, so for Cu2 plus, you can see oxidation state of copper is here, that is Cu2 plus now. So 2 electrons from the s orbital will be lost. So it will be 4s0 3d9. So write the paired now in the d orbital. So it will be dxy, dyz, 3dxzx, 3dx square y square, 3dz square. So one electrons are there. First fill one electron in the suborbital, right? So 5, 6, 7, 8, 9, right? So one electron is unpaired electron, last one, right? So n equal to 1. How many unpaired electrons are there? 1, right? Unpaired electron get excited to higher energy level, but it remains unpaired, right? Because there is no chance for pairing. So it will be remaining unpaired due to a strong field ligands. Here in this compound, NH3 is a strong field ligands, a strong field ligands, right? So n equal to 1. One unpaired electron can't be paired. One unpaired electron cannot paired, right? Paired with other orbital, because there is no space, right? So this much you have to just find it. N equal to 1 unpaired electrons are there. So write it down, asked in 2016. Now look at the question number 14. Which of the following is an outer orbital complex exhibits paramagnetic behavior? Right. So options are given. It is asked in 2012. So see those orbital which utilize 3D orbital for bonding and exhibits paramagnetic behavior from outer orbital will be. So see for the first option like nickel NH3 6 raised to 2 plus. So nickel atomic number is, how will you get it? Scandium, it starts from 21, right? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, right? So it is 21, 22, 23, 24, 25, 26, 27, 28. So nickel atomic number is 28. So its electronic configuration will be argon 4s2 3d. How much? So last electron total, how many numbers are there? So that will be in the d, right? So it is 3d8, right? So after losing 2 electrons, because oxidation state is here, assigned with nickel is +2, so it will be Ni +2. So it will be argon 4s2. So 2 electrons will be lost from s orbital, so it will be 4s0 3d8, right? Now do the electronic distribution in orbitals. So only d are remaining, right? So 5 suborbitals of d is there, 1 2 3 4 5. So give one electron to the each d orbital. So 5 6 7 8, right? 2 unpaired electrons are there, right? So that is paramagnetic behavior. It is already told, right? So these are the last of these two will be unpaired electron. These two, it is unpaired electron. Unpaired electron means substance will be paramagnetic. Paramagnetic, right? So it will use the outer electronic configuration. So how many ligands are there? 6 total. So after 3D it comes, after 3D it will be coming as 4S, 4S, right? Next it will be 4P and use then 4D. So total 6 ligands are there. So ligands will be filling here electron in the 4S, 4PX, 4PY, 4PZ. So it is 4S, 4PX, 4P, Y, 4P, Z. Total 6 are there. So 1, 2, 3, 4, 5, 6 ligands will be filling this suborbital. Right. So this will be 3dxy, 3dyz. Understood? So hybridization will be sp3d2. Right. So this will be the explanation for first option. Now see for the second one. When there is Zn NH3 6 raised to 2 plus. So outer configuration, but it is dimagnetic. Here we are using outer orbital complex or outer, yeah, orbital complex. Outer orbital complex, but dimagnetic. Why it is so? That is due to the pair of electrons. So C for the zinc. So uh, uh, iron, cobalt, nickel, copper, zinc. So zinc comes under the 30 atomic number, right? So electronic configuration last will be 4s, argon 4s2 3d10, right? So after losing 2 electron, it will be remaining only 4s0 3d10, right? So D, all D will be paired. So if there all electrons are paired, then it is called diamagnetic. Very simple. All are paired. All are paired. So it is diamagnetic. So that is the explanation for B option. Now C for the second C. That is chromium. It is attached with NH3 6 times raised to 3 plus, right? So its electronic configuration will be, see the previous slides, chromium is 24. So it will be argon 4s1 3d5, right? So 5 unpaired electrons are there. It is paramagnetic, but it will be inner paired, inner orbital complex, but paramagnetic, paramagnetic. Now see for the D option. D option is CONH3 6 raised to 3 plus. Right. So it will be inner orbital. Inner orbital. See, cobalt is there, right? So see the electronic configuration for cobalt. So cobalt is 27 now. So cobalt is 27 atomic number. So it will be argon 4s0 4s2, right? 3d7. So unpaired electrons are there, right? But it is diamagnetic due to the paired. So how it will do? 1 2 3 4 5. 1 2 3 4 5. So 1 1 2 3 4 5 6 7. So these are, so cobalt is losing how many electrons? 3 now. After losing 3 electrons, this will be gone now. Now see in the next slide. Cobalt atomic number is 27. So its electronic configuration is argon 4s 2 3d7. So its electronic distribution after losing now, so it is cobalt 3 plus. So it will be 4s0 3d6. 1 2 3 4 5 6 oh 4. So this will be removed, right? So it will do inner orbital. So for inner orbital, this electron will come here and this electron will be coming here. Then it will become like this. 1 2 3 4 5 6, right? So this is called diamagnetic. Write it down. Now look at the question number 15. Which of the following complex ion which is diamagnetic in nature? So you have to find about the diamagnetic nature of the complex. Diamagnetic nature, it is asked in 2011. So see, so first option I will explain, that is NiCN4 raised to 2 minus, right? So for nickel 2 plus, last electronic configuration will be 3d8 4s0. So it will show the electronic distribution in d orbitals. 1 2 3 4 5 6 7 8, right? And cyanide is strong field ligand, so it will do the pairing, inner orbital pairing. So one electron will be coming here, right? So right here Cn minus is strong field ligands, so it will do the pairing, strong field ligands. Thus it pair up the electron right? So outer orbital will be used. So here 1d will be used, 1d. So it will be 3d z square, and after that s orbital will be used. This is a 4s. Next is p orbitals. So this will be 4px, 4p, y. So total 4 ligands are there. So it will, one will be coming here, 2, 3, 4. So 4 ligands. So hybridization will be DSP2. 1D is used here, right? 1S is used and 2P are using. So its hybridization will be DSP. Hybridization. Understood? So all electrons are paired, right, in this. So it will be diamagnetic. So first option is matching, right? So it will be diamagnetic nature. Understood? So please write it down. Now look at the question number 16. Which of the following complex ion is not expected to absorb visual light? Right. So see the explanation here. It is asking about visible light. So see the explanation for first option. For the absorption of visual light, presence of unpaired electron is necessary, right? So please write the statement first. Absorption of for absorption of visible light, presence of unpaired d electron is necessity. So its electronic configuration for the first option will be Ni2, oxidation state for nickel, right? So its last electronic configuration will be argon 3d84s0. So a strong field ligands is there, cyanide is there, right? In the complex like NiCN4 raised to 2 minus, right? So it will do the strong field ligands after losing the electron. So its distribution of electron will be like this: 1, 2, 3, 4, 5, 6, 7, 8. So last d orbital, that is 3d z square, 3d z square. So don't write this one, right? And it will do the bonding with the 4s and 2p orbital. So it will be 4px, 4py, right? So two electrons will be paired, right? So what will be the hybridization for NiCN4? It will be DsP2. Understood? Due to the strong field ligands. So pairing occurs because cyanide, a strong field ligands, doesn't contain any unpaired electrons. So it doesn't absorb visible light, right? So no unpaired electron is there. No unpaired electron is there. So no visible light. So write the explanation. Now see the next question number 17. Crystal field stabilization energy for high spin. So it is talking about crystal field stabilization energy. In short form, we can write CFSU, right? So it is nothing but crystal field stabilization. Stabilization energy for high spin. For high spin, that is 3d4 octahedral complex. Octahedral complex. Right, see the explanation. So it will be for high orbital, it will be degenerated, right? So I will write the explanation here. For high spin 3D4 octahedral complex. So 4 electrons are there in the d orbitals. So then it will degenerate. Degenerate d orbital. So it will be distributed into two parts. Upper part is 0.6 delta naught. Lower part is 0.4 delta. So 3 electron will be here and 1 electron will be on the upper part. Right. So this is the degeneration of the d orbital. So write about CFAC, crystal field splitting. So how it is calculated? So 3 electrons are there, so it will be minus 3 into 0.4 plus 1 into 0.6 delta naught. So how much it is? It is minus 1.4 plus 0.6, 0.2 this will be, right? So it is equal to minus 0.6 delta naught. So this will be the answer. So your option is D. So whose value is minus 0.6 delta naught.